TCP and UDP comparing transport protocols. Host-to-host layer protocols. Transmission Control Protocol (TCP) and User Datagram Protocol (UDP). TCP is connection-oriented in the sense that prior to transmission endpoints, it needs to establish a connection first. TCP protocol data units are called segments. The sending and receiving TCP entities exchange data into the form of segments, which consist of a fixed 20-byte header, followed by a variable size data field. TCP is responsible for breaking down a stream of bytes into segments and reconnecting them at the other end, retransmitting whatever might be lost, and also organizing the segments in the correct order. The segment size is restricted by the maximum transfer unit, or MTU, of the underlying link layer technology. MTU is generally 1500 bytes, which is the maximum payload size of the Ethernet. The TCP segment format. User Datagram Protocol, or UDP. Unlike TCP, UDP is connectionless, where data packets can be sent without warning, preparation, or negotiation. There's no handshake or setup, just packets of data. UDP also lacks any kind of error control. Not only can packets be delivered in an incorrect order, but it can also get completely left out. UDP is meant for applications where you are more concerned with keeping the stream of information going than making sure you receive every single packet. UDP is ideal for real-time services such as voice over IP. With TCP, delays happen every time there's an error like packet loss. VoIP do not require completely reliable transport layer protocol. Why it matters for VoIP. The UDP and TCP protocols come into play with VoIP because they structure the way web traffic travels through the internet. TCP and UDP packets are sent from a source to your phone or computer, and if any of these packets are dropped, it will affect the quality of your call.